So our next problem is check whether the number is power of 4 or not. Okay, so let's take some example. So 4 is to power 0 will be 1. Okay, again 0 is not a power of 4. Okay, 0 is not a power of 2, 4, 8, 16, whatever. 0 is not a power of 4. Now 4 is to power 1 is 4. 4 is to power 2 is 16. 4 is to power 3 is 16 fours are 64, like this. Okay, so the power of 4 are like 1, 4, 16, 64, like this. Okay, now again the same thing. In a power of 4 also, we will have only one set bit. Okay, we will have only one set bit, that we will see. Now, what can be my first approach? My first approach will be same as my first approach of power of 2. Okay, so these are the series of problems: power of 2, power of 4, power of 8, power of 16. Okay, so all the approaches will be same. So let's discuss the approach 1. Okay, what if I divide the number, if I keep on dividing the number by 4. Okay, first finding the remainder. Okay, let me write it. So first find the remainder. Okay, if it is 1, it means that it is odd. It is odd. If it is odd, it cannot be power of 4. Okay, second thing, if it is 0, if it is even, still there is a chances that it cannot be a power of 4. Okay, so 6 is not a power of 4. Okay, 10 is not a power of 4. So if it is even, if it is even, again just divide the number by 4. Okay, and keep doing this. So let's say if I take 15, so 15 mod 4 equals to 1. It means it is odd. Odd cannot be a power of 4. Okay, so I can simply turn. Now I will take 16. So if I take 16, 16 mod 4 is 0. It means it is even. So check further. So first divide the number by 4. So 16 divided by 4. My number will be 4. Okay. Again, again check. 4 divided by 4 mod 4 will be 0. It is even. Okay. It is even. Again, divide the number. Number equals to number divided by 4. Okay. So again, it will be 4 divided by 4 will be 1. So if you get 1, it means that it is a power of 4. Why? Because a number 16. So 16 can be written as 4 into 4. Okay. So one time you are dividing, so it will be 1. Again, you are dividing by 4, so it will be 1. Okay. So it will be 1 at the end if it is a power of 4. So let's take 18. 18 mod 4. Okay. 18 mod 4 will be, it will not 0, right? So it will be 2. You can simply turn from here itself. Okay. So that's how you can calculate power of 4. Okay. And how much time it will take? It will take almost log base 4 your number. Okay. So this is our first approach. Now I want to tell you the second approach. Okay. Second approach. So in second approach, what you can do? You can check. First check if it is a power of 2 or not. It is a power of 2 or not. If it is not a power of 2, it will not be a power of 4. Okay, so first check if it is a power of 2. If it is a power of 2, then take num mod 3. If you are checking power of 4, take num mod 3. Okay, so if your number mod 3 equals to 1, it means that power of it is a power of 4. Okay, so this is a simple algorithm. First check if it is a power of 2 or not. Okay, if it is a power of 2, it means that it will have only one set bit. If it is a power of 2, and if it is a power of 2, check if number mod 3 is equals to 1. Okay, so let's take one example. Let's say 16 only. So in number line you can write 1, 2, 4, 8, 16, 32, 64, like this. Okay, it will be 0, 0, 1, 0, 0, 0, 0, like this. Okay, now Check if it is a power of 2. Yes. So 2 raised to power 4 is equals to 16, right? So if it is a power of 2, yes. Check for another condition. 16 mod 3. 16 mod 3 is 1. So if it is a power of 4. Okay. Now check 32. 32 is a power of 2. Okay. 32 is a power of 2. 2 is to power 5 can be written as 32. Now check if 32 mod 3. 32 mod 3 will be 2. Okay. It is not 1. So it is not a power of 4. Okay. Check for 64. So 64 is a power of 2, right? We can write it as 2 is power 6. Okay. Now check 64 mod 3. 64 mod 3 is nothing but 1. Okay. 3 to 21, right? So it will be 1. So it is a power of 4. Okay. So this is our second approach. Check whether the number is a power of 2. If it is a power of 2, then check if the number is mod 3 equals to 1 or not. Okay. If it is not a power of 2, then it is not a power of 4 also. Okay. This is our second approach. Now, the third one and the interesting one. So in the second approach, see what we are doing. We are first checking power of 2 and then we are doing this mod function. Okay. There is one more way. So let's discuss the third approach. So let's take an example. Let's say 16. Okay. So if I write, it will be 1, 2, 4, 8, 16, 32, 64, 128, like this. So this bit will be 0, this will be 0, this will be 0, this will be 1, 0, 0, 0, 0. Okay. And now if I write, what is the 4 raised to power 0? It is 1. What is the 4 raised to power 1? It is 4. What is the 4 raised to power 2? It is 16. What is 4 raised to power 3? It is 64. Okay. So if we observe, so my this bit, so this bit and this bit and this bit. Okay. So my number will be power of 4 if my only bit is set at any of this position, any of these position. Okay. First, it should be a power of 2. If it is not a power of 2, it cannot be a power of 4. Okay. So first it should be a power of 2, then only we'll check. Why? Because see, 0. 0 is not a power of 2, right? So it could not be a power of 4. Okay. So it should be a power of 2. Okay. It should be a power of 2. Then only we'll check for power of 4. That is my first condition. Okay. So if it is a power of 2, we'll have only one set bit. We have only one set bit at any of these places. If it is a power of 2. But in a power of 4, if it is a power of 4, my only set bit will be at this position. Okay. So if it is a power of 2, my only set bit will be set in any of this position. Okay. But if it is a power of 4, my set bit will be only set at this position or this position or this position and so on. Okay. So I want to create a mask. Okay. I want to create a mask for what? So let's take this example. Let's say 16. Okay. It can be written as 1, 2, 4, 8, 16, 32, 64. Okay. So it will be 1 here and all zeros. Okay. Now I want to find a mask. I want to find a mask which should result in zeros. Which should result 0 if it is a power of 4. If it is a power of 4. Okay. In power of 2 also, what we are checking? If my answer, see, in Bryan Karnick algorithms, if it was giving 0, it means it is a power of 2. That's why I'm taking the same pattern. Okay. There can be multiple ways to take the mask. But I'm checking for 0. Okay. So if my result is 0, it means it is a power of 4. So first I will check whether my number is power of 2 or not. If it is a power of 2, then I will check this. Otherwise, if it is not a power of 2, then it cannot be power of 4, power of 8, power of 16 and so on. Okay. So first condition is to check if it is a power of 2. Okay, after this we are checking for this. Okay, now just see this carefully. Okay, observe carefully. If my number is a power of 4, so this is my number of power of 4. This can be power of 4. This can be power of 4. This can be power of 4. So if you observe, every alternate bit is a power of 4. If you observe, every alternate bit is a power of 4. Okay, so I'll take a mask such that if my number is a power of 4, it should always result in 0. Again, I'm repeating, I want to take a mask such that if my number is a power of 4, which can be possible only when my this bit or this bit or this bit or this bit is set. Okay, so only bit at this position, if only the bit at this position is set, then only my number will be power of 4. So I want to create a mask such that I always get 0 in answer if it is a power of 4. Okay, how I can do that? So what I will do, what my idea is, I'll take I'll take these bits as zeros. Okay, in those bits where power of 4 is possible, I'll take those bits as 0 and rest as ones. Okay, so now if I take 16, so this will be 1. Okay, and 1 and 0 will always result in 0. So if I take this, if I take 16, 16 is 1 0 0 zeros, all zeros. Okay, only this bit is 1. And if I do AND with 0, it will result in 0. Okay, otherwise take this. If you take 64, if you take 64, it will be 0. Okay, if you take 8, if you take 8, it will be 1 here, so it will be non-zero. So if it is non-zero, it is not a power of 4. So 8 is not a power of 4, right? So that's my idea. What I will do, I want to take, let me write clearly. So I'll take these bits as zeros, okay, where the power of 4 is possible, and rest as ones. Okay, why? Because I want to find the pattern where my answer will be 0, because I want to create such mask where my answer should be 0 when we have the number which is power of 4. Okay, you can create another mask. Okay, you can create the mask for non-zeros as well. Okay, if you want to find the answer as non-zero, then you can create the mask. Okay, just invert the bits, then it will be fine, right? But I want to follow the same pattern as power of 2. Okay, I want to follow the same pattern as power of 2. So in power of 2, if my answer was 0, it was power of 2. Okay, similarly in this also, if my answer is 0, that means it is my power of 4. Okay, and similar pattern I will follow in power of 8 and 16 as well. Okay, if you are not comfortable with this, just take the another mask. Okay, if you want to find for non-zero, take reverse the mask. Take the mask accordingly. Okay, now my mask will be like 0 1 0 1 0 1 0 1 0 1, this only. Okay, but is it a good idea to write the whole mask every time? Okay, so is it a good idea to take this mask like this? Okay, so let's say in integer is of size 4 bytes. Let's take 4 bytes. 4 byte means 32 bit. Okay, so if you write 0 1 0 1 0 1 0 1 32 times, let me write 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 1 2 3 4 5 6 7 and 8. Okay, so this will be my mask. This is my mask. Okay, so either you write the whole mask. Okay, either you write the whole mask or just convert it in hexadecimal, right? So how to convert it in hexadecimal? How to convert this in hexadecimal? Just take this. Just take a pair of 4 bits. Okay, take a pair of 4 bits and convert it in hexadecimal. Convert it in hexadecimal. Okay, so if you convert this in hexadecimal, it will be, this is 8 and this is 2, 10. 10 can be written as A. So this will be A, 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 this will be A. Okay, so these are 8 A's, 3, 3, 2. These are 8 A's. Okay, you can write it like this also. 0x 8 A's, 4 A's, 4 A's. Okay, 3, 6, 8. Okay, so you can write your mask like this also. Okay, I hope you got it. See, I am again repeating. What you can do, you can check whether your number is power of 2 or not. If it is not a power of 2, just return false from there itself. If it is a power of 2, then check for this condition. Okay, so I will create a mask. I have created the mask like this. Okay, I have created the mask like this. So if I do number, I'm writing here, if I do number and your mask, if it is 0, that means it is a power of 4. If it is not 0, if it is non-zero, that means it is a not a power of 4, not a power of 4. So if I'm doing AND of my number with mask, if it is 0, it will be power of 4. If it is non-zero, it is not a power of 4. Okay, now how I created this mask? How I created this mask? So just check the pattern. Check the pattern. If my number is a power of 4, so these are the bits 1, 4, 16, 64. So this any of this bit will be 1. So if 4 is to power 0 is 1, 4 is to power 1 is 4, 4 is to power 2 is 16, 4 is to power 3 is 64, like this. So what I will do, I want to find the answer as 0. Okay, if it is a power of 2. So I will put zeros in the bits where the power of 4 can be possible. Okay, and I'll put ones to the rest of the bits. Okay, I'll put zeros to the places where the power of 4 can be possible. Okay, so power of 4 can be possible here, power of 4 can be possible here, power of 4 can be possible here, power of 4 can be possible here. Okay, and if it is 0, if it is 0, it is a power of 4. If it is non-zero, it is not a power of 4. Okay, so this we need to take care. Now you do vice versa also. Okay, so you can take 1 here and 0 at the places where it is not a power of 4. No issues, right? Then what will happen? Your mask will be different. Okay, so then your mask will be 0 1 0 1 0 1 0 1, like this. Okay, so it is nothing but this is 4 and 1 5. So your mask will be 8 times 5. Okay, if you convert it in hexadecimal. So 3 6 8. Okay, whatever you feel suitable, you can use it. Okay, so you can use this mask and you can check. So if you do and mask, if it is 1, that means it is a power of 4. Okay, if it is 0, that means this is not a power of 4. Okay, if you take this mask. So depending on whatever mask you are taking and whatever output you are generating. Okay, I am comfortable with this one. Why? Because in power of 2 we were getting 0. Okay, so that's how I created this mask. Every time I will check if it is 0 or not. So this is all about this problem, I guess, and I hope it is clear to you. So I've already written all this in my notes. Okay, so if you want to find my notes, you can just go through my profile in LinkedIn. It is Kapil Yadav. Okay, 22, and you can download the notes from document section. Okay, go to the document section, you can find my notes. Okay, or on LinkedIn just write bit manipulation notes, you will get it. Write bit manipulation notes. Okay, you will easily get it. I have written the detailed notes of it. Okay, everything I have explained here I have already written in my notes. So this is all about this problem. I guess we have discussed 3 approaches, right? So first one approach was dividing by 4. Second approach was to check whether it's a power of 2 and then take a mod of 3. And my third approach was this one. Okay, so third approach is the important one, right? So it is using our bit manipulation logic. Okay, it is using our bit manipulation logic building. So this is all about this problem, and let's discuss the next problem.